back, chemistry fans. Here is your second video for the day 71, I believe it is. Sorry, I'm not there again. I am up doing Eclipse stuff. So I hope you enjoyed it, or I hope you will enjoy it. And I will see you again on next week sometime. All right, so let me share with you my screen so that we can get into the warm-up. And what we are going to do to review you for this exam is take a look at these Gibbs free energy. Now, again, remember what these values each stand for in this problem. So this equation is given to you. It's on your cheat sheet. G is Gibbs free energy. It is a measure of, is this reaction going to be thermodynamically favored or not, is the key words, but we know that to be spontaneous or non-spontaneous. H is heat. S is entropy. It's a measure of randomness. And so if you have a high entropy positive value, that means the particles are very far apart. If it is negative, the particles are very close together. And of course, temperature is going to be measured in Kelvin for this. So we must add 273 to that temperature. That's the first thing that we got to do. So 273 plus 19, that's going to give us 292. And then we've got all the other values. So what we're doing is we're just plugging this in literally into that equation. H is negative 638.4 minus the 292 times the delta S. Now here, though, it is in joules. It must be in Kelvin. I'm sorry, it must be in kilojoules. So we need to divide that by 1,000 to turn that into kilojoules. So I'm going to do 292 times 156.9 divided by 1,000. And then we're going to make that a negative value. So that's negative 45.8. And then we're going to add to that a negative 638.4. So those are summative whenever they're both negative. And you get 45.8. And you get negative 684.2. Now, the second part of this question, it asks, is this spontaneous or not? So you have to know what negative implies. Negative G's mean that it is spontaneous. It is spontaneous. The phrase for that is exergonic. That's the new phrase. Now, not only is it thermodynamically favored, but we also need to associate a negative, just like we had with exothermic. Exergonic is the term that we are using that means that it is spontaneous. So all of these three terms, thermodynamically favored, spontaneous, exergonic, all mean the same thing. All right, jumping in now to number 2. What we've got is a heat of this reaction, and it's products minus reactants. Again, all of these equations are on your reaction. The 25 degrees does not matter because we're not going to use G equals H minus TS. We're just going to do products minus reactants for this. And so here's my reaction. My products are on the right. My reactants are on the left. So CO2 is negative 394.4, but there are 2 moles of that, so I need to multiply it by 2. There are 2 moles of water, so that's going to be negative 228.6. And again, multiply that by 2. Now the reactants, it's minus the negative 389.45. Because they are both negative, that's going to make them positive, and the oxygen has a 0, so it does not actually affect it any. So now we just distribute those 2's and add them together. So 394.4 times 2, and that's a negative, minus 2 times 228.6, plus 389.45. And what we get is negative 856.55. And again, our answer here is going to be spontaneous, and it is going to be exergonic. Okay? So this is the review that I was hoping for you for the last topics that we covered over spontaneity last class. Thank you very much for your time. I will check back in with you very shortly, and hopefully be back middle of the week. Talk to you again soon. Bye-bye.